Hey guys.
Hello.
So I'm waiting on the Pear Deck to load and it's keeps giving me an error. So I may just have to do the slideshow without it.
Hello.
Hey there.
They updated Zoom.
Say again?
They updated Zoom. Everything looks weird.
They did update it, yes. To 5.0, I think they said. All right, I'm gonna try to relaunch it one more time. I may just have to go on without this Pear Deck. Yep. Let's see here. Out of the way. Okay, come here. Thank you all for being patient. It's not behaving. All right, you all can just you can see the slideshow, right? Can you all see the slideshow on the screen? Okay. Okay, how am I going to do this since it won't launch? All right, so we'll just pick up where we left off on Friday. Thank you guys for coming. And real quick reminder, we talked about a bar graph. Could someone remind me what's the basic purpose of a bar graph? What about Betty? You're the first person I see on the list here.
The bar graph is to get like all the data, like under like one subject and see what's like has the most. Kind of like when you go around and like have like a few subjects, like let's say yes or no, or like how many people like one subject.
Right. So it's ask a question that has multiple answers. That's why it's called a statistical question. And then you just put those into bars. Notice there has to be spaces between the bars, meaning they're separate answers. And what is your X, Kylie? What is the purpose of your X axis on a bar graph?
It's to tell you what the amount of or what your
choices are, the things are, right?
Yeah.
It's the stuff in the question, right? The answers to the question. So the x-axis would be the answers to the question. Then what, Permita, would the y-axis be for?
So if the x-axis is for like the questions, the y-axis would be the quantity of like the answers.
Perfect. So that was something I don't remember if we said or not, but the purpose in a bar graph, the x-axis's purpose is always going to be the answers to that question. And then the y-axis, which is dependent upon the x. You see, it makes sense because you got to know what the thing I'm talking about is to know what the number of it is. So that's why the y-axis has to be the number. Okay, any question about that? Just going to run through each one of them. All right. Okay, how am I going to advance the slide? It's not moving. Okay, hang on just a second here. Let me try this. All right, I'm having to literally just tap the graph. I mean the slide. You can see the slide, right? Okay, so this is a multiple bar graph. James Hood, will you tell me what makes it different from a bar graph?
You can have a bunch of different things that you're measuring. Kind of like a histogram, except instead of like different groups of buckets, you have actually like different things.
So yeah, so you watched the video because you said the word buckets, right? Yep,
Mhm.
That's in the Ed puzzle. I caught that. I saw that you listened. Okay, so yeah. So instead of having 4 different bar graphs there about favorite superheroes for kids age 1 versus age 2 versus age 3, they just put them all together. And so then they made the ages of the children the x-axis, and different color bars are the choices, right? So if that were just a single bar graph, the choices would have been the 4 things on the X, right? Does that make sense? So the title, if it were a single bar graph, the title would become Favorite Superhero of Children Age 1. Then Mighty Man and Lovely Lady, or whatever they were called, I can't see the other part of it because of the Zoom, would all be the X's, the x-axis, and then the numbers, the y. And then you'd have another bar graph for age 2, another bar for 3, another one for age 4, etc. All right. We also talked about a circle graph. Josie, tell me, what is the job of a circle graph?
The job for it is for you to see like the whole, the different sections of the whole, and so you can compare and contrast them.
So could you remind us how you actually would create one? I mean, not the literal math, but what do you have to do to make a circle graph? You just ask questions and put them in a slice of the pie?
Well, you have to have what it's like the title, which is what it's all about.
Uh-huh. So this is what, so
the
this,
whole of all of the sections, and then you.
so the sections would be the X or the Y? That's hard, isn't it? I threw a new question out there. So on the pie chart, the circle graph, the X would be the selection, the slices, right? Because aren't those the answers to the statistical question? Right? Correct? The choices?
Correct.
So people said oatmeal cream pie, chocolate cupcakes, fudge brownies, zebra, etc. All right. And then, so that's true. And then the Y would be all of those percents, right? Could someone elaborate on how the percents you got from the Y? How did you get the percents from the Y-axis? Could someone elaborate on that?
Is it because they would all equal up to the total of the whole circle?
Correct. So you would add up all the bars of all the answer choices, numbers, that would become your whole, and then you would make a fraction from each Y number over the whole, right? So like if there were 100 people, there would be a 2 under honey buns. There'd be a 3 under fudge rounds. There'd be a 2 under cosmic brownies. There'd be a 5 for Star Crunch. And those would be 5 out of 100, 2 out of 100, 6 100s, 4 100s. And that's your percents. If it's less than 100, if the number's not 100, you have to do the equivalent fraction to a percent, right? So yeah, or decimal to percent. Okay, yeah. All right, now then we started Friday talking about line graphs. And let me ask Kimani, do you mind to help us understand the purpose of a line graph? What would be the
purpose of a line graph?
Yes.
Is to chart the ratings of a certain count of a certain number or percentage of something over a long period of time.
Okay, that's the key word. You're tracking the change of the data over time. So this could be the number. So the people who answered yes to a survey on Monday, Tuesday, Wednesday, Thursday, Friday. Could a line graph even talk about, I'm going to fill up the bathtub with water? Could a line graph tell me about that? Does anybody have an idea how a line graph might tell me about filling up a tub of water in a bathtub?
Me, Mr. P.
Okay, Graham.
So it would show the rate of which water entered the bathtub,
Exactly.
which would probably be going up at probably linear if you're adding it the same amount of time.
Okay, let's unpack what he just said. All of that's correct. It would be a graph with a positive slope going up. It would be linear because you probably would turn it on at a certain amount on the faucet and then leave it, right? And the Y would be the amount of liquid in the tub, correct? And the X would be what? You okay, Mason? What would the X be?
Me or somebody else?
Anybody? What would the X be? On
The
that.
X would be the amount of time.
Okay, key point. The X is always going to be the time.
Because it's changed over time.
Correct. The Y is going to be the amount of change. The X is always going to be the time. And so that's why the time's always along the X-axis, right? For example, okay, I'm going to take you back to ratios, rates. Let's say I'm saying to you, I'm packing lockers at the rate of 1 locker per 5 minutes. That's a line graph, right? So along the X-axis, I would have 5, 10, 15, 20, 25, 30, 35 minutes, right? Along the Y, I would have number of bags packed. And wouldn't that be the way the division problem would be? It'd be bags over time? Yes. So that's why that would be for a line graph. So it makes sense. Does anybody remember the line graph we looked at Friday? This one on the screen? There were a couple of clues on there that would make it very clear what the topic of this line graph was, even though it doesn't say.
Oh, I remember what it was.
Yeah, you actually got it. So let's see if somebody else remembers what Graham said.
Wasn't it boiling water cooling down?
Yep, it was boiling water. So this scenario here is likely a tea kettle that hit a boil. It was boiling because water boils at 100 degrees Celsius. That's Celsius, 212 Fahrenheit. And then they turned the eye off, right? And it started to cool down. We also talked about right here, that was probably where they poured some into a cup because it cooled at a steeper rate, meaning faster. Then they probably set it back on and then it just generally cooled off, right? Remember we talked about the slope here being about the same through here and approximately here, but here it's steeper. So meaning it was getting cooler faster. All right, take a moment to look at this graph. And on the Pear Deck, you were going to draw move arrow buttons over to where you saw the steepest slope. So this graph is about sulfur dioxide emissions over the last 250 years, 170 years actually. Sulfur dioxide emissions over the last 170 years. So take a moment and tell me, where was the greatest amount of sulfur dioxide emission? About what year was the worst pollution of sulfur dioxide?
Excuse me, Mr. P, was the Pear Deck?
So the Pear Deck won't load. It keeps giving
Oh.
an error, so I couldn't launch it. I tried like multiple
So
times.
text it?
No, it won't run on my computer.
No, I mean like text it to you. Like text our
Oh,
answer?
no. Oh, sorry. No, I want somebody to just answer that out loud. Thank you, Graham.
Oh, okay.
Somebody could just answer that out loud. At what point?
When
Go ahead.
it was, do you want to know when it was the highest or like when it went up by a lot?
So that's two different things, right?
Yeah.
Yeah, I want to know when it was the most emissions, the highest emissions.
Okay.
So the lowest at the beginning of the graph in the 1800s, right? Almost not a lot. Maybe almost none. Would we say it was about 1980? About 1980?
Yes.
Yeah.
But it's like really hard to see the numbers.
Yeah.
Okay, so it's right here, isn't it? Yeah, it probably is hard to see, isn't it? All right, so there it is. Now, Pramita, you asked another question. You said, is there a, and she's right, there's another point at which it was increasing the most, and that would be right here. Why would it be right here between 1950 and 1970?
Because there was a dramatic like increase than all the other ones.
So what mathematically tells you is more dramatic increase, Jayla? The starts with an S. The slope. It's steeper, right? Isn't this the steepest place? Think of it like this. Say you're walking up this hill, this mountain. Where's the hardest part to walk? Here. Why? All of us know why. Why is this the hardest part? Steepest, right? This is the hardest part because it's the steepest. That would almost be impossible to climb, wouldn't it? You'd have to have like some kind of like stakes to put in the earth, right? So that's called the slope. So here the slope is the highest. So between 1950 and 1970, we were increasing that pollution at the most rapid rate. Okay. What else do you notice? So that's a positive slope. These are new things. I'm just telling you, this is pre-algebra stuff. This is a positive slope. Okay. Right here. What is this right here? Can y'all see me moving the arrow? What is that?
A negative slope.
You got it. It's a negative slope because it's going down. Do you notice that between 1990 and around 2000, it almost decreased the amount as much as it was increasing in the 60s? Would you agree with that statement? You can shake your head. Yes, you should, because if you'll notice here, the slope of this positive climb, which is negative for pollution, but this increase here is about the same steepness as this decrease over here is, right? Does anybody know what you call a curve like this? Anybody know what you call that? Okay, it's a bell curve. So a bell curve is where let me see if I can annotate that. A bell curve is this. Teaching. So this would be a bell curve, right? Yes. All right, that's a bell curve. Dr. Rossi is coming in the room. Oh, yeah. Here, guys, look. Here's Dr. Rossi.
How's everybody doing?
Most of them are
Good.
Good. Are y'all having fun at home?
No. Yes.
No.
Are y'all excited about coming back to school to drop off your items?
Yes, honestly.
I am. Yes, I am.
Yes.
I'm getting ready to scan your textbooks in. I hope everybody have their textbooks here so no one has to pay a fine.
Okay.
Okay.
All right. So hang on, guys. And I'll help do those too when I get done. Okay, there you are. I'll help do those.
You want to let me give it to you when you're done?
Yeah.
Okay.
Yeah. And the rest of the sixth grade's on that table out there.
Okay.
All right. Okay. So, this is called a bell curve. This would be what generally, it doesn't guarantee it, but this would be generally what grade distribution would look like. Let me see if you can see what I'm doing here. All right. So do you see I have 5 categories there? Those categories would actually be people's grades. Like that would be A's. This would be B's. This would be C's. D's. And F's. Where's the F? So in other words, on most general grades, the most people make C's. The next most amount of people make D's or B's, and the fewest make F's and A's over generally speaking. So that's a bell curve. Do you notice there's a bell curve a little bit over here in this sulfur dioxide emissions? So you can see that it goes up and comes back down like that. So would you say, somebody who hasn't talked could maybe say, would you say that this graph shows a positive, encouraging sign about pollution of this particular kind?
I would say back and forth, kind of. It's bad that it spiked, but it's good that it's going back down.
Right. So it currently appears that it's coming down, but it's still not very low, right? But it's come down. Look how much lower it is than it was in like 1980s, 40 years ago, right? But it's still higher than it was in the 60s. So yes and no is a great way to say that. That's right. Okay. Really quickly, moving on. I hope this was okay. Let me get out of this. All right. Okay. So maybe I can hear from somebody I haven't heard from. What's going on in this graph? What do you notice about this graph that's different from all the graphs we've looked at so far? What's different? Let me call on somebody. What's different? Josie, have I heard from you?
Yes.
Okay, do you care to tell me?
Sure.
What do you notice it's different on this graph?
In this graph, there are, for the year 2017, it had a decrease, but then it had a really big increase. And then
how do you know that? Because you're looking at the key that says the green line is 2017, right?
Mm-hmm.
All right, yeah. And Mason, what do you notice about the graph?
They also have a line that's red.
And it represents 2018. We don't know what it is. It could be anything, right? Could this be temperature change? Why would you want to say no? Okay, guys, look at it. This cannot be temperature. Why? Look at the y-axis.
There's one that's really high, like at 150 at December, November, October.
Okay, first of all, let's look at the y-axis. We don't have temperatures in the hundreds, 180.
He said, okay. He said, hey guys, why?
No, it was called
and because there's no like key that says it's in like degrees or anything, or Fahrenheit.
All right.
Or Celsius.
So we know that it couldn't be temperature because of the y-axis. The numbers wouldn't work, right? Now, let's say the y-axis numbers are gone. Why could it still not be temperature?
Because the between here and here is too much. It's too much of a difference, right?
Mm-hmm.
All right. So who's saying that? Is that Kimani? Who was that? Kimani, was that you? All right. Whoever it was, yes. Aren't the changes too drastic?
Yes.
And do you notice on one of them, it's higher in the summer for part of it, and then it goes way down in July, but way back up in August? That doesn't make sense, does it? And the other year, it's not like that. Wouldn't the temperatures be similar in the both years? So see, you could make you could write an argument of why this is not a temperature change and say lots of things. The Y doesn't work. The graph's change doesn't work. The hot months should be in the summer months and the cool months in the winter months. It's not necessarily that way. So yeah, what really quickly might this be? Let me
I
hear.
have an idea.
Okay, Graham, go.
Tons of plastic that end up in the ocean every month.
Okay. All right, somebody else. What else might it be? Melis, what do you think? I'm gonna call some people I haven't heard from. Izzy, what do you think? Are you all not able to get your mics on? Nathaniel, can you get your mic on? Tell me what you think possibly this graph could be about.
I can't see all of the graph because your face is in the way. Like your camera. Like,
Oh,
so
okay.
like, yeah.
I don't think I can move it. I think that's just the way it is on your thing. All right, let me just, I know it's because the Pear Deck's not working. Okay, so on the Y, it goes up to 180 and it's months. Could this be money you've earned at a job? Like say you're working a job that you do after school. Could this be your monthly earnings? Would that be a feasible graph? Answer is yeah. And on one of the years, you had more money earned in the spring and in the fall. And on the other one, you had more earned in January, right? So that would be a possibility. All right, let's look at another one. Okay, I know it's hard to see. So this one is about wildlife population. And you notice now you have the years, and you have, instead of having separate line graphs for 3 different animals, you put them all on the same line graph. So I've got bears in blue, I've got dolphins in orange, and I got whales in gray. So just give me one general characteristic. Which animal's population is going up the most?
The bears.
Bears.
The bears in blue. Do you notice an animal that's population is decreasing?
Dolphins.
Dolphins. And is one of them approximately staying around the same?
The whales.
Yes. So can you see that? That's exactly right. But looking at those 3 lines, you can see one animal is increasing in population, one is decreasing, and one's staying around the same over these several years that are being shown, these 6 years. All right. And then here, do you notice anything? Is there anything about this particular line graph that you think is maybe not good, that it could be done differently? What errors do you see that there may be with this line graph? I'll give you just a moment to think about it, and then I'll take volunteers. And if I don't have any volunteers, I'll call on some people. All right, so on the Y, I've got from 0 up to 180. And on the X, I've got week 1, week 2, week 3, week 4, week 5, and the title says cookies. So I'll take either what this graph's about or something about it that maybe is not displayed correct the best way.
I think different graph types might be able to show this a little better.
Okay. So what graph maybe? So let me ask.
Could organize the weeks via histogram, I suppose, but that wouldn't be the most effective way.
So a histogram.
And this does display change over time, so
it could be a line graph, but do you think maybe a bar graph would be better?
That's what I was maybe thinking, but that doesn't really show change over time quite as well.
But it does, though, if you set up the X to be the time, right?
Yeah.
So it's possible. Does anybody think maybe it's not good that they have the lines drawn, that it should be a scatter plot? Because are they between week 1 and week 2, are they selling cookies on all these days, or do you think it's okay to have the line?
I think it's okay.
Okay. And the answer is either way is okay, because the line's purpose there is not saying I'm selling parts of box of cookies. That's not what the line is saying. The line is showing you that it went down this steepness, it went up this steepness, it went right. So the point of the lines are to show you its change, but understand that you're not doing partial cookies in between there.
I think that they should just put a dot on the places that they actually sold it.
You're right. In other words, that's for me why a bar graph might be good here, because you just look at the bars changing, right? Thank you, Ms. Heidelberg. You can put them right there. That's great. No, that's right there. It's fine. Thank you. So yeah, so I think maybe a bar graph would serve just as well. Would a circle graph be appropriate? Would a circle graph be an appropriate measure here? Izzy, what do you think? Angelo, can you tell me what you think? Would a circle graph be appropriate here?
No.
It would not. That's right. That doesn't really, you could do it, but it really doesn't help you understand the data. So it's not really the best use of your graph. Okay, so we're going to stop there for today. So just a reminder, if there is something you need to let me know about your lockers, I'm packing up locker stuff right now and desks. Like I've gotten all the textbooks out and Dr. Rossi, and we're scanning. If you're wanting all your stuff, some of you answered the tech test like I asked you to. If there's some things I could throw away, please let me know, because the thing is your bags are going to be really full and I don't know if they're going to bust. Also, the 4-H projects, you won't get them back on Thursday, but I will keep them and you can get them when the new school year starts, because there's nowhere to put them because we're so tight on space down there. So they're going to have to stay in the room and I will move them back to the new building. Back to Meg's, and then you can get them when school starts. All right. And if I could also do this, if there are some things that won't fit in your bag that you could live without over the summer, I could give them to you in the fall. And also, I don't think the math workbook, the reading workbook or the math books are going to be able to come because of the fact you have so much stuff. So I will keep those in a box. And if you really want them back, you can get them in the fall. Or you can tell me on text, I don't want them. All right. So if there's anything you can do without, and text me so I don't have to put it in your bag to carry it down there, because we're having to literally carry each of those garbage bags downstairs. So if there's stuff you don't want, if you want it, it's great. But if you're not going to keep it, then don't make us pack it down there and they have to lug it out to your car. But if you want it, it's great. All right. So just let me.
Summer homework?
Mr. P, when are we going there? When are we picking this stuff up?
So Thursday afternoon from 1 to 5 is 6th grade time, and that's when you'll drive up. And your parents got email directions about how to drop off and pick up. Like you can't get out of the car. They literally have to bring the stuff out and put it in your car or hand it to you or whatever. Nobody's allowed to get out. And like if you have band instruments or things to turn back in, there'll be different tables. You go and stop and give those things to whoever's at that table. Like if you have a library book, you'll give it to, there's a spot you'll stop and give that. If you have a textbook, there's a table, you'll give that to somebody. Instruments have a spot, but there's an email for all that. And more details will come before Thursday, but it's Thursday afternoon from 1 to 5 for 6th graders. Somebody have a question?
Yeah.
Yes.
Mr. P, this Thursday or next Thursday?
This Thursday, May 21st. Betty, question?
Are we having summer homework?
No.
When will the report cards come?
So a couple things. So we'll have Zoom, our regular lesson tomorrow and Wednesday. Then Thursday, that'll be the last day of class on Wednesday. And then Thursday, we'll have our Zoom, but it'll be for our Mr. P Awards, but it'll have to be at 10 o'clock. So that morning will be 1 hour earlier because I have to come and help with loading stuff at 12. So that I have to have time to get here. So we'll do the Mr. P Awards at 10, and then the afternoon you pick up stuff. Report cards will be sent mailed out at the 1st of June after school is over. So they won't come until like week after next, because they'll close out on Thursday. And you won't have summer homework, but Metro will probably send out some enrichment stuff people could do if they want to over the summer. But I'm saying you all are going to be good, because if you've stayed with everything I've done, we've gotten everything. We're finishing up the last 2 or 3 things this week, and you've got everything covered for 6th grade.
Are we still going to have to do the summer reading stuff?
There'll be so probably not, but they'll be sending out some details about that. Probably because of all the weirdness of this year, that won't happen. It may just be a suggestion. You can read it if you want, but probably there won't be a required summer reading. But that hasn't been totally decided yet, but that's the general direction it's headed. Does that make sense? Please don't forget to text me if there are things of yours that you don't want that I can recycle or throw out reuse or recycle. Like, I noticed there's a lot of things in lockers that are like supplies you haven't used, which I'm glad for you to take them home, or you can donate them to somebody else if you don't want them. But I don't want them just to be tossed after they're packed up. So if you don't want it, please let me know. If you do, I'm happy to do it though. Okay? All right. Hopefully the Pear Deck will work tomorrow. And tomorrow we'll do histograms, and Wednesday we'll do box and whisker plots, and that'll have all of the math finished. And mostly there's 2 new ed puzzles this week. Today there's one tomorrow. And then basically it's finishing up. If you have any of the things not finished, those are important to finish, because that's where a lot of the content's being given that I can't say in person, right? All right. Okay. So we won't do a gym kit today, but we will do a gym kit tomorrow, because I'll be at home normal tomorrow. So we'll do that at 11. Oh, and then there will be a gym kit on Wednesday, and it will be all 6th grade, and it'll probably be at 12 noon. So there will be a gym kit with the class tomorrow, and there'll be a gym kit for 6th grade on Wednesday, but it'll be at 12, I think, on Wednesday. All right. Any other questions about your stuff? And again, feel free to text me if you have a question. And like, I know a couple of you wanted to see a picture of your things, and I sent them. So if that's you and you need to see a picture of something, just text me and I can send you a picture. All right? Okay?
See you guys.
Okay, see you guys tomorrow at 11. All right.
Bye.
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 Bye.